Hello again, everybody. We're back for another exciting physics lecture, and today we're going to do a little more with waves. So this will be the second video lecture on that, waves number 2, we're going to call it. All right, today we're going to talk about adding up waves. You will not need any equation sheet today, so that's good news, no math, but you are going to have to make some pretty careful drawings, so perhaps a little graph paper might come in handy, or just you're going to have to draw pretty carefully on your paper. A couple colors may come in handy as well. So I'll let you grab those, pause me, and then we'll continue. Welcome back. Here we go. Let's start. I'm going to have a string with 2 waves on it. Now, I'm an awful drawer, so let's pretend these are exactly the same shape. They're semi-close, I guess. And then we're going to assume they're going towards each other with the same velocity, with identical velocities. Let's watch this string as time goes by. And I hope you had seen some of this with some of the demos we've done in class. So here the waves go. They're getting really close. They're getting ready to bang into each other. And notice something. As soon as they start to hit, both parts add together in the middle. All right, so you'll notice that while each one of them would have been a little bit lower right in between the waves, each of their little parts add up. And then what we end up with in the end is this ginormous wave in the middle as they're crossing, and then the waves separate in our last picture and go their separate ways. Now, a couple things. These waves are always moving along at the same speed, but what's weird is, let's have a look right when they're crossing each other, right in here. Okay? What happens is, they add together, but at that instant, they look like one wave, even though they're going in different directions. And there's 2 waves there. The instant they're on top of each other, they look like one wave twice as big. All right? And I hope you had seen a little bit of that today when we did some of the demos. Now let's make this a little harder. Let's have 2 waves going towards each other just like before, except one of them is on the other side of the string. Okay? So as we go along here, they're getting closer, and the waves are just touching. Now, I'd like you to predict, see if you can predict what's going to happen when they cross each other. So go ahead and pause, and then see if you can predict what's going to happen. All right, did you get your drawing? How did you do? The wave completely disappears if those 2 separate waves are identical. When they overlap, they should exactly cancel each other out. Now, check out that string. It's completely flat for a split second, and yet there's 2 waves going on it at the same time. That's really bizarre. All right, now, it's just a split second that you see that, and then, boom, the waves continue on their merry way. But again, the magic part, the cool part, happens right there. The instant they're on top of each other, the waves cancel each other out, and it looks like there's nothing there just for a second. Now, both of these ideas are going to be really important as we come closer, all right? And the idea is this, that equal waves on opposite end of the string cancel out, equal waves on the same side of the string add together. The easy way to remember that is waves always just add together. If they're on opposite sides of the string, they're going to kind of cancel each other out. If they're on the same side, they'll add together. So here we go. Let's make things a little more difficult. This is the part you may need some colors and some careful paper. So I have a green wave on a string, and it's going to the right with a velocity of v. And I keep wiggling my string up and down and up and down and up and down and up and down. Okay, this is a snapshot in time of my string. Okay? Now, I also have a wave on a string going the other way. So now I have to be on the right side wiggling the string, and the wave is moving to the left with the same velocity. Okay? Same wavelength and same period. And what I'm going to do is I'm going to do that to the string from both sides at the same time. All right? Now here's what you do. You choose a spot on your graph. Let's choose the first red line right here. Okay? And notice what we have. We have 5 little boxes up on the green one and 5 little boxes down. So right there we have nothing. If we move over, both strings, well, they're supposed to be at 0, are at 0. So when we add them together, again, we have nothing. Check it out. What you should end up with is the red string 100% canceled out. All right? Now, this is just for an instant. Okay? So this wouldn't happen forever, but for an instant, that's what we get. Now, let's move on and check out what I'm going to do. The green line and the blue line are where the waves were just like a second ago. Now, let's move forward and take another picture a second later. Those are my dotted lines. Okay? So the green wave is moved to the right, blue wave is moved to the left. Once again, let's take a dotted line, go down and see what we get. So right here, we have 0 and 0, so we should end up with 0. But at this line, notice we're with the dotted lines now, we have both waves positive, so they add together. So they would go up 10 little boxes or 2 of the big red ones. All right? If we keep doing that, I want you to predict what the wave is going to look like and see if you can continue all the way out and make the resulting wave down below. So pause me, and then when you're ready, continue. All righty, here we go. So our red dotted line now, notice something. The amplitude is twice as big as either one of those waves, the green or the blue. All right? And we have a couple places that haven't moved. Notice on my black dotted lines here, these places were not moving in the last wave a second ago, and this second, they're still not moving. All right? Now, in your mind, or if you want to draw this, move the green dotted wave to the right, one more red box, and the blue dotted wave to the left, one more red box. All right? See if you can do that in your head and predict what wave you're going to get. Okay? Give that a try. See what you come up with. Then do it again. All right? I want you to do those twice, and I'll give you the answers here in just a second. So try that, and then pause and start up when you're ready. All righty. Hopefully you got it. Here's the result of our first 2 drawings. All right? From our original, and I'm going to jump backwards, from our original green and blue wave, we ended up flat. That is right here, our top graph. From our dotted green and blue waves, we ended up with a huge wave. That's my second wave right there. All right, now we moved the green and the blue forward. One more second. You got a flat wave again. Move them forward one more second, and you got a huge wave again, but check it out. It's exactly opposite the wave, the huge wave from above. We just made resonance on the string. Okay? Notice something. We have spots that never, ever move on the string. Right there. See my dotted lines? Right there. Right there. All right. This should remind you exactly of the demo from today, I hope, that we watched. Okay? So here we go. We have this ginormous wave going back and forth, and there's a couple spots that are never moving. Resonance. Okay? One more word you have to remember. Okay? The spots that never move are called nodes. So we The spots that never move are called the nodes. Alrighty? Here's your homework. Your quiz for tomorrow, sorry, you're working on your homework. Quiz for tomorrow is this. We have two waves. Now notice I drew some square and triangle waves here. One's kind of a trapezoid or something. One's a square. Then we're going to move towards each other. And my string is 11 meters long. And when I give it a shake to make the wave, the waves are 5 meters high. These are huge. They're going to be going towards each other. Here's what your job is. Draw the next 5 seconds as these waves cross by each other. What would the result look like? So you're going to have to redraw this 5 times. And here's what I would do. Draw it right one above the other. Okay, so right below this one, I would draw the axes again and move the waves forward 1 second. Then draw the axes below it again, another second. Continue that 5 more seconds as the waves pass through each other. All right? Now, here's the trick. I want you to just do it straight on the paper you're going to turn in. Okay? So the quiz tomorrow, you're actually going to be done with when you walk in the room. Okay? It's on your quiz paper, and it's completely done. All right? Well, happy work. Enjoy yourselves, and we'll see you tomorrow.